In today's episode, Annika asks, important functions of AI with big data are analyzing the past, predicting the future, and prescribing future strategies, according to the Marketing AI Institute. What else do you know to be important use cases for AI in marketing? So, this is one of the most important things we need to understand about AI is that it isn't just a collection of random solutions and operations, right? What we have happening here is an attempt to try to understand what AI can do and conflate it with business outcomes. And those are two different things. So what we need to do is dig into the operations, the capabilities of AI, machine learning particularly, and understand that framework first, and that it's not random and that it's not just a collection of disconnected point solutions. Understand the framework, the structure first, and then apply it to the business outcomes we care about. So let's look at what this framework looks like. In fact, let's bring it up here. So artificial intelligence, machine learning in particular, is good at 4 types of problems, right? In the upper left, you have 2 types of problems you're trying to solve. You either know the outcome you're looking for, which is called supervised learning, or you don't know what you're looking for. You have a big pile of data and you're trying to make sense of it. That's called unsupervised learning. So that's the top. Along the left-hand side, you have 2 types of data. You have numbers, continuous data, metrics, and you have non-numbers, so stuff that's categorical in nature, dimensions, descriptors, things like that. An example of continuous data, of course, is any kind of number. Categorical data would be things like place names, channels in Google Analytics, right? Facebook. So you see this grid: supervised, unsupervised, continuous, categorical. In each of these 4 categories, there are different types of techniques. So for when you know the outcome you're after and you have numbers, you can do regression and prediction. So regression, very straightforward mathematical operations, right? Prediction, very similar. That's where you get things like gradient boosting. That's where you get things like GBM, XGBoost, even just good old-fashioned regular linear regression. All of that is to find the outcome you're looking for, right? So you want to know, for example, what drives website traffic or what drives conversions. So regression and prediction. Time series forecasting is also in this bucket as well, because it's a form of regression. When you have unsupervised machine learning and continuous data, you have clustering. So you have a bunch of numbers. How do they cluster together? How do they relate to each other? This is a great way to dig into things like, for example, SEO data. When you have a lot of SEO data, you have a lot of different numbers: domain authority, link authority, inbound links, outbound links, number of words, etc. They're all numbers. How do they relate to each other? You need to cluster it first to start making sense of the data, and only then would you then flip back over to regression and say, okay, now that I've made sense of the data, which of these clusters has a relationship to high search rankings? So clustering is a very important set of techniques. We use it a lot. Classification and categorization and categorical, supervised. This is all speech recognition. Image recognition, video recognition. This is classifying sentiment analysis, things like that. Anything that is non-numerical, you're going to be doing a ton of this classifying. Bayesian learning and stuff is all in here. Logistic regression is in here. And those, of course, there are obvious applications: speech recognition, natural language processing, and so on and so forth, are all in the classification bucket. And then association and dimension reduction, that's where you get a lot of natural language understanding. So trying to understand the words, the phrases, the bigrams, trigrams in text. You see a lot of that You see it in the first stages of image recognition as well, before you go to classification, just trying to pick out the noise from the image. What's foreground, what's background. When you understand this framework of the types of machine learning, then you can start mapping it to those business outcomes. But you have to understand this first. If you don't have this stuff down first and understand the techniques that go in each of these buckets, it becomes very, very difficult to make sense of AI. Because what happens, of course, is that it just gets too messy, right? And if you don't have this in your head, then you don't have the underlying techniques that go in it. So in supervised, you have, for example, ordinal regression, random forest regression, boosted tree regression, linear regression. And unsupervised, you have k-means clustering, covariance clustering. For categorical stuff, you have decision trees, logistic regression, neural networks, nearest neighbor. I mentioned Bayesian early. For association and dimension reduction, you have stuff like PCA, LDA, CCA, TSNE. But if you don't understand these things and you don't understand the techniques inside of each of them, then it becomes very difficult to apply them correctly. So understand this stuff first and the techniques within them, and then start thinking about, okay, now how do I apply this to business outcomes? If you don't have the command of the techniques, then one of the consequences of this is that it becomes very easy for vendors to fool you. It becomes very, very easy for vendors to take advantage of you. Just say, oh yeah, we use machine learning. We use, can you imagine a vendor saying, we used advanced machine learning and proprietary dimension reduction techniques to predict the future? Well, no. You may do dimension reduction to clean up the data, but if you're predicting using dimension reduction techniques, you're literally doing things completely opposite of the way they should be. So it's important for marketers to have this vocabulary. You don't necessarily need to write the code, but you need to understand the techniques involved in order to map them to use cases. Once you understand the data each works with and the techniques in each, then finding use cases for all this stuff is very, very straightforward. Not easy, but straightforward. So an important question, because understand this stuff first and then go hunting for use cases for AI and machine learning. A lot to unpack here, a lot to study. I'm still learning. Everybody I know in the field is still learning. There's new techniques being developed all the time, or improvements to techniques, so keep that in mind. As always, please leave your comments below, subscribe to the YouTube channel and to the newsletter. I'll talk to you soon.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.